So now that we kind of talked about more uh, about programming and what you can actually implement in terms of programming, let's talk more about the difference between syntax and style. So this has to do with kind of the conventions of being a programmer. So if you think of a programming language as basically any other language, you can think of syntax versus style as like grammar versus your writing style. So whenever you write something in English, right, you know that there's a proper grammar that makes sense, right, that everyone else can understand. There's a difference between running all your words together and not including spaces and not being grammatically correct versus being the kind of person that always uses therefore at the end of their sentences. So these things are the difference between a syntax and style. It's the same thing as grammar versus writing style. So the syntax of a computer language is actually a set of rules that actually defines the combinations of symbols that are considered to be correctly structured statements or expressions in that language. So if you ever defy the syntax of a certain code, you are doing something wrong. Your computer will throw a bunch of errors at you and you won't be able to run anything. Versus programming style is a set of rules or guidelines basically that is used when writing the code. And the reason why we have style in the first place is just to make programming so much more easier and so much more readable for other people that are looking at your code. Because one thing that you have to always remember is that computer science is actually kind of a group and a community effort. So whenever you write programs, you're not writing it just for yourself. You are going to be sharing it with others in your work or your day-to-day life, or if you put it on a GitHub, open repository, share it with other people. So you want to make it in a way that's not only understandable for the computer in terms of syntax, but also understandable for other people in terms of style. So an example of what is proper style is actually being properly indented. So C++ itself does not actually have strict rules on indentation. That basically means indentation is not a part of its syntax. And this is something that I kind of touched upon before when I was talking about the blank lines. We said that we're on line 3. I said that blank lines have no effect on a program. So this space doesn't going to do anything if you get rid of it. But the reason why we might have it there is to actually improve readability. We wouldn't want our main function to be so close next to our preprocessor definition, because if somebody else is going to look at our code, they might think that looks really ugly and they get scared and they don't really understand what's going on with it. So indentation for C++ is just style. It's not syntax. So this is an exercise / example, but using the code that you just had now, what happens if you delete all the indentations and spacing in your Hello World program? So I'll just show you an example. I'm going to show you what I want you guys to kind of do. If you want to follow along, you can, or else you can just see my screen. But we see a bunch of spaces here, right? So let's say that we got rid of every single one of these spaces. We don't have these indentations anymore. We run everything along together, okay? Now, either through the chat or you can unmute yourself or whatever, what do you think is going to happen when I actually run this program and why? So if we run this, no errors. So good guess. Actually, I was kind of hoping that somebody would say that, because the whole entire point of this is you would think, honestly, that this is something that's completely wrong. Because when you look at it as a programmer, when you look at it as a human, this whole entire thing is a mess. As if I was a computer, I would throw a bunch of errors at this. But like I just said, C++ is different in that it doesn't care about indentation. It doesn't care about spacing. We include a bunch of indentation to actually help ourselves. We have nice stipulated lines. We have these things available to us in order to help us out as programmers as a whole. But the output would be the same no matter what. But our program just looks so much more nicer and cleaner. And that's the difference between syntax and style. Syntax would mean that we throw a bunch of random errors if we have them all together. But style is there because we want to make it more readable. So I hope that makes more sense. Okay, so again, nothing changed with or without indentation. It had the same effect, but this isn't the same for all languages, actually. So an important point to note, oh yes, okay, I will repeat what I just said. So basically the key takeaway from all of this is that indentation for C++ doesn't matter. Whether or not you have extra spacing doesn't matter. And the example that we just showed was a key part of noticing the difference between syntax and style. So like I said, syntax would mean that you have a bunch of errors being thrown at you because you didn't indent properly. But style is that like all of your friends hate you because your program isn't indented properly and nobody can read what that is. But it still works on the computer. So if you guys do eventually start learning other programming languages, for example, if you learn Python, indentation does count as syntax. So a note about this is that don't think that all the rules that we learned here in this week and that you learn about C++ applies to all of the programming languages. It's the same thing like learning Spanish isn't the same thing as learning English. So there are different rules that you have to understand when it comes to like communicating in both languages. But it's just a cool note that like in C++, indentation is actually a style error. While in Python, just like Josiah said, if you were actually to do this in Python, you would be completely having a bunch of errors and your computer wouldn't be working. So it's just an important distinction to make. And again, in C++, you always separate statements between using semicolons. So the separation of different lines doesn't matter by indentation. This is an example of syntax. So for example, if I were to take, if I were to actually get rid of all of the semicolons at the end of my sentence, you get these squiggly lines here. And these squiggly lines tell us that this is an error. So if we were to run this, this is when a bunch of errors happen. Because the computer doesn't read new lines by looking at the indentation. Instead, it looks at new lines by looking at the semicolons, which we talked about before too. That semicolons determine the ends of the sentences. It's like periods at the end of like an English sentence. So that's why semicolons are more important in C++ than indentation. And not having semicolons counts as a syntactical error rather than a style error because your computer will throw a bunch of errors at you. So yeah, I hope this makes sense to everybody. Does anybody have any questions so far? Okay, I'm going to take the deafening silence as a no. Now let's go on to the next page, which is syntax versus style again. So this has to do kind of with those preprocessor directives that we had before. So, okay, sorry. So preprocessor directives are general rules. They are not statements. So I'll explain this more when I actually show the program, but it's really important that you understand that anything that begins with the hashtag, right? Like how we had the hashtag IOStream, it is not the same thing as a statement because our program is not actually doing anything with that. It's something that's actually occurring even before your program is even compiled, even before you are, like the program is even run in the first place. It's just meant to be specified in their own line, and because they're not statements, they don't have to have a semicolon. So every statement needs a semicolon, but because preprocessor directives are not statements, they don't need a semicolon. So just to like show you what I mean by that. Again, if I go to my replit, I got rid of these semicolons here, but if you notice on here, my preprocessor directive include IOStream doesn't have a semicolon. And in fact, if I put a semicolon there, you actually get this little tilde sign. You get that error because that's not supposed to be there in the first place. It's a warning. Okay, so excellent question. Why do we need preprocessor directives? So preprocessor directives are important because it actually lets you run the functions that you need to run. So in this case, preprocessor directives are telling us that we are going to be using inputs and outputs for our program. So without this include IOStream, basically none of these like calls to functions like std count, none of these like statements that we give can anymore be even used in the first place. So it kind of goes into like libraries. So if you know what that is, great. But if you don't, it's just basically a bunch of code that has actually already been used before. So this hashtag include IOStream is a library itself of data, of information that basically tells the computer that we are going to be outputting something into our screen. And without that IOStream, without like these preprocessor directives, you can't even actually run fundamental commands to your computer. So it is like a very essential part of your computer. So if you want to have like outputs or inputs, which we'll talk about later, inputs. But like if you want to like print out to your computer hello world, you need IO stream to even like define what that output even is in the first place. So like what is an output to the computer? So IO stream is just like a way for your computer to understand how to create something and how to put it out into your computer. And then you as a programmer define what it is that you actually want to output. So I hope that makes a little bit more sense. But yeah, preprocessor directives won't ever use a semicolon because they aren't statements, they are directives. And so putting a semicolon would get you a warning, and we don't like warnings as programmers. So, next part. Now we're going to run our second C++ program. So, if you are familiar with C++ already, you might have seen something that looks like this. So this might be actually your first Hello World program, and it depends on your teacher, it depends like how they share it with you. But there's actually some key differences between this Hello World program and the Hello World program that we actually created before. So what I'm going to do is give you guys like 5 minutes, so it's like 3:29 now, we'll go until 3:35. I want you to actually, either using Replit or your MinGW, create like a new text file or rewrite a new REPL on your account and basically write this out and run it and see what happens. So when you try out this program, the only difference between the one that we had before and the one that we're doing now is that we're using cout, like count, instead of std, then we have the : count. They both basically name the same object. So the second program uses its unqualified name, which is our cout, while the second one uses, the first one uses its qualified directly within the namespace std as std count. So if you remember, our program actually didn't have this using namespace, and it had std count. But now because we have using namespace std, we only write out count. But like, why do we even have this difference in the first place, right? So count is actually part of the standard library. And what it does is like names the elements that are standard to C++, and it's declared in what is called the namespace. So in this case, namespace std. So in order to refer to the elements in the std namespace, a program should either qualify each and every use of the library, which we had done with std count, or introduce visibility of its components. So the most typical way to introduce this is by means of using declarations, like using namespace. And this is what's actually being done after the IO stream. So the above declaration, like this one, does use the namespace, so we are using declarations, and so we don't have to write out std count each time. While in this case, we are showing std namespace to be accessed in an unqualified manner, so we're without using the std prefix. So both ways of accessing elements, explicit and using declarations, are completely valid, and they should produce the exact same behavior. There were some people who had errors, and there's some people who aren't to double check it, so we'll look over the code right now. But for simplicity and to improve readability, the examples in our tutorials will more often actually use declarations, like how we did here. So basically for the rest of the week, we won't be using std count anymore, we'll just be using namespace. But I wanted to kind of introduce to you what this std count looks like, because that's something that would show up like often when it comes to C++ beginner tutorials. Like you guys notice when you open Replit, that's the first thing that they actually provided for you. But of course, there's like other ways of writing it out, like how I showed here. So for simplicity, we would be using declarations, but the reason why they might have used std count instead of this newer form that we showcased here is because explicit qualifications is the only way to guarantee that name collisions never happen. So name collisions basically just refer to like having the same name being referring to like the same statement or like the same function, and that kind of output kind of creates the computer to becoming more confused. So explicit qualifications means that every time we write out std, so every time the computer knows exactly what we're referring to. But in this case, when we don't have that, the computer gets confused and it doesn't know exactly what it's pointing to, which right now doesn't matter, but later on becomes a problem. Let's look at like what that would look like to the computer. If I can get out of here. Okay. Okay, cool. Let's see what Replit's doing for us. So we have our program out here. like we said before, this is like what kind of like shows up automatically onto your screen. But we're going to be showing it as taking rid of our std couch. So we can only do that if we say that we're going to be including or using namespace std instead. And basically this is the exact same thing. So notice how the only thing that I actually changed in between was I wrote count instead of like std count, and then I wrote using namespace std. So now I don't even have to write it multiple times. So let's see what's happening here. It should get us hello world. So for anyone having any issues with it, is this like kind of the screen that you have? It's okay to like if you wanted to include another part to it. So like if you wanted to say, for example, I'm a C++ programmer. Again, it's just doing the exact same thing, no difference. Because again, all we're doing is just getting rid of the std count, and the reason we can do that is by using our namespace. So, any questions about what's the difference between these two? Why are you getting any more errors? This is what your screen should look like.